Today we are starting a new chapter, and have a look at the calendar that we have ahead of us. I made a combination of November and December, so we can have a look what we have ahead of us. And check it out. This week, we are on this week here, and we're going to start chapter 3, System of Linear Equations, and we're going to have in total 19 days. Well, less than 4 weeks, because this week we still have a holiday. We're going to have a holiday, so it's not a complete week. So it's going to be 1, 2, 3, 4 weeks, less 1 day, one holiday, Veterans Day, to this week on Wednesday. And we're going to have lots of breaks and holidays and days off. Actually, on November and December, we're only going to have 4 weeks of classes. If you check, we have Thanksgiving the whole week. Then on December 14, it starts the midterm exams, flex days. So we're not going to talk about chapter 3. It's going to be exams and flex days. The second quarter ends, and after that, we already are on winter break. So very little time on November, December, just 4 weeks to work the whole chapter 3. Serenity. Oh no, don't worry, Serenity. Hello, Adrian. As long as you open your assignment, you're gonna have your attendance. Don't worry. No school Wednesday, Kalia. No school Wednesday. No school, no assignment, no meeting, nothing. Just relax. Veterans Day. You can work by yourself if you want. You can study, you can do any quizzes by yourself, but nothing is going to be assigned. Yay! For chapter 3, we have 4 different topics, and so we have 4 weeks. Each week we're going to try to cover one of these topics. The first topic is 3.1, solving system of linear equations by graphing. The second topic, 3.2, solving systems of linear equations by substitution. The third topic, solving systems of linear equations by addition. And finally, linear inequalities and systems of linear inequalities. Those are the 4 topics that we're going to cover on these 4 weeks. And today we are starting with section 3.1, solving systems of linear equations by graphing methods. The first thing actually that we need to understand, that we need to talk about, is what is a solution. First, before that, what is a system of linear equations? What is a system of linear equations? We know what is a linear equation, right? If you check here, you have one linear equation here. That's getting red. This is one linear equation. And in blue, you have another linear equation right here. So each one is a different linear equation. And we know what this means. We know how to graph. We know how to evaluate. Right? We kind of worked a little bit on linear equations. But what is system of linear equations? Very simply, putting it very simple, in a very simple way, is when you have 2 or more equations with 2 or more variables. This is a system of linear equations. 2 or more equations with 2 or more variables. So if you combine, if you have these 2 equations here and 2 variables, x and y, then you have a system of linear equations. A solution to a system of linear equations is an ordered pair that is a solution to each individual linear equation. So to be a solution to the system, it needs to be a solution for each one of the equations. And that's, putting very simply, that's it. That's what means solution for a linear equation is a point or an order pair that's going to be a solution for each one of the equations. All right, maybe confusing when we talk, when we show, we try to explain by giving you all these definitions, but might be easier to understand when we work on the example, okay? So let's work on one example here that might be easier to understand. Determine the order pairs are solutions or not to the system. And the system is this. We have the equation number 1, x plus y equals -6. Let's see, this is equation number 1. And equation number 2, 3x minus y equals -2. Let's say this is equation number 2. And both equations, they make the system. They are the system of equations. Check if the order pair, that's the first one, this one, the order pair, -2 and -4, if they are solution for the system. When we say this is an order pair, that means this is x, right? X equals -2 and y equals -4. This is an order pair. We will plug in to find out if this is a solution. I'm going to plug in into the equation. So letter A, first thing to do, bring the equation number 1. Bring equation number 1 here. Equation number 1 is going to be x plus y equals -6. This is equation number 1, right? Plug in x equals -2, y equals -4, and find out if this is a true statement. Is -2 minus -4 equals -6? Yes or no? And the answer here is going to be yes. -2 minus -4, -2 minus 4 is -6, and this is true statement, equals -6. Yes. Good. This means it might be, this point might be a solution if it is also solution to the next equation, the next one, number 2. Let's try. Plug in. Now we have 3x minus y equals -2, right? So plug in into the next equation. 3 times x equals -2. Let me just redo this. -2 minus y, and y is -4, minus -4. Is this equals to -2? I don't know yet. Let's check. Let's check. 3 times -2, -6. Let me squeeze a little bit here. -6. Negative with negative, positive. Positive 4. Is it equals -2? -6 plus 4. Yes, -6 plus 4 is -2. This is a true statement. And that means, yes, this is going to be a solution for both. So this is a solution for the system of equations. Oh, yes. Okay. Good morning, Jermaine. Good morning. Now try the next one. Let's check the next one. Oops. Let's try the next one. Oh. The next order pair that we have here is this. Thank you, Will. Thank you. Let's write in blue, okay, in blue. And we're going to work out this one here. 1. The equation x plus y equals -6. Equals -6. Plug in x equals 0 plus -6 equals -6. And this is actually true, right? This is true. -6 equals -6. Nice. Maybe this next one is also a solution. Let's check the next equation. To be a solution needs to be to both. Needs to be a solution to both equations. 3 times 0 minus -6 equals to -2. Oops! Just to conclude here, so you just a quick repetition here, quick repetition, just to make sure you got it. To make sure this is a solution for the system, the order pair must produce a true statement for each one of the equations, of both equations that makes the system of equations. So on letter A, yes, it is a solution. On letter B, no, it's not a solution for the system of equations. Bell work first, and then we move to the quiz. The bell work is simple. The question here is, when my father was 25, I was 4. Now he's twice as old as me. How old am I? How old am I? Can you answer this question? Type your answers, type your guesses, and let's check. So the age of the dad, when he was 40 years old, is 25. So this is the age of the dad. And what's interesting, what's happening with these two lines? Yeah, he's twice as old as him. What's happening with two lines? They are parallel. They are parallel lines. Because every time 1 year passes by, then both are going to have a birthday, right? Both are going to add 1 year to the age. So when he's 5 years old, he's going to be 26. When he's 6 years old, he's going to be 27, and so on and on and on. What is constant? What's going to be constant here is the slope and the distance between the graphs. This distance here, 25 minus 4, this distance is going to be 21. So the distance between the graphs is going to be 21 years, and it's constant. It's moving constantly. At some point, this age of the dad is going to be double the age of the son. So this is 21. What is the age of the son that makes the age of the dad double? Double of the age of the son. You're going to always add 21. 21 is the gap, the age gap between the son and the dad, right? That means you have to add 21. 21 plus 21, 42. When the son is 21, the age of the dad is going to be 42. That means the answer actually is 21 years old. This is the answer to our bell work today. Okay? This is the right answer. That makes the age of the dad double. 21 plus 21, 42. This is just a warm-up. This bell work is kind of a warm-up. So we get ready, right? Our brain is prepared to work on the quiz. It's a warm-up for the brain. And now we're ready. We can say we are ready to work on the quiz. Our brain is ready. So let's move to the quiz. And the quiz today, 2 parts. The first part is like the example that we worked before. You have to find if the order pairs are solutions for each system of equation. And the second part, very easy. Find the solution of the system of linear equations by finding the coordinates of each ordered pair. So let me show the second part here first, because it's too easy. Check it out. This is the solution, is the intersection, right? The point of intersection. Then you're going to find the coordinate, and the coordinate is x and y. What is x and what is y of this point here? And x is going to be point number 2, right? X equals number 2. And y is going to be y equals number 1. That means the solution for this system of equation is 2 and negative 1. This is going to be the solution. That's what you're going to do with the next question, H, I, and J. Just find the coordinate of the solution. And the solution is the intersection point. Let's get back here to the first part, and I'm going to explain again, because Kalia said she didn't understand yet, and maybe we can understand here. We can understand now. And let me zoom in. We will work on the first letter A. We have the system of equation, right? And the system is here, these two equations. Let's say this is equation number 1 and number 2. Okay? We have two equations with two different variables. Let's try, the first one that we're going to try is this. Order pair x equals -1, y equals to 1. So, equation number 1, y equals 8x minus 5. This is equation number 1. And we will plug in x equals -1, y equals 1. So x equals -1, -1 here, and y equals to 1, right? So 1 equals 8 times x, -1, minus 5. This is how you check. Now you have to check if this is a true statement. 8 times -1, -8, minus 5, -13. What is this, true or false? This is false, right? This is false. That means you don't even need to try the next equation, because if it's not solution to one equation, it's not solution to the system. So this is a no, not solution to the system. Now let's try the next one, okay? Let's try the next one. Next one is this order pair here, x equals 2, y equals 11. Try for equation number 1. Equation number 1 is y equals 8x minus 5. Plug in y equals 11. 8 times x equals 2 minus 5. See? This is y, see, y, and this is x. Let's check if this is a true statement. 11 equals 8 times 2, 8 times 2, 16, minus 5, 11. 11 equals 11. Is this true? Yes. Yes, nice. 11 equals 11. Great. Now second equation. Y equals what? 4x plus 3. Plug in y equals 11 and x equals 2. Oops. The next equation is 4 times 2 plus 3. This is the second equation. Plug in x equals 11 y equals 11 and x equals 2. Y equals 11 and x equals 2. That's here. And let's check. Too much stuff going on. Too much stuff. That's right, Kalia. 4 times 2, 8 plus 3. 8 plus 3, 11. Is 11 equals 11? Yes. That means this one, yes. This is a solution for the system. Yeah. And I agree with Kalia. It's kind of a lot of work. It's a lot of work. You have to do a lot of calculations, right? You have to do lots of calculations. And you can get your calculator to help you out. You just need to be careful, so you plug in the right number into the right places. And tomorrow, this is one way of doing this. Tomorrow, I'm gonna find other methods that are gonna be kind of more straightforward, more easy to find the answers. All I need to do is plug in the x, the other parameter of the x, and that's exactly what you have to do, you. That's right. Just need to be careful to plug in the right places, and that's it. It might be a lot of work, but it's not. I'm gonna tell you, it's not difficult to understand. But after you understand what you have to do, is a little bit of hard work because it's kind of a lot of calculations. Yes, and I agree with this. I can agree with this. All right, this is the solution for letter A. I'm gonna give you a couple of minutes to work on the next questions. Letter B, C, D, E, F, and then we can work together again. Okay, let me give you a couple of minutes to work by yourselves.